Welcome to part 4 of converting a dead CDJ 1000 Mark III to MIDI with a teensy. So this video is all about the MFLB board, and we're going to convert all of the buttons and all of the LEDs to direct connections. The LEDs have a slight issue, which we'll see later on. Some of the buttons are direct, some of the buttons we need to isolate just like before. So this is nothing that we haven't done before, there's just a lot more of it. So we're currently going through all the buttons and all the LEDs on the board, just so you can see what it is that we're dealing with. So this first part is the digital buttons. So the buttons that are directly linked to the CPU, they're not linked together in any way. So that's the hot cue buttons, loop in, loop out, and reloop. So just like before, we're going to wire onto the positive leg of each switch, but on these direct buttons, we don't need to remove any resistors. So we can see here that I've already done that. We've done that before, so I didn't think I need to show you. So we have the reloop button, we have loop out, and we have loop in. And now we have the three hot cues. So hot cue A, hot cue B, and hot cue C. So now we are on to the analog style buttons that have the resistors. So we're going to cut the tracks on the buttons, and if needed to, remove the resistors. Actually, thinking about it now, a lot of the times we don't actually have to remove the resistors. As long as we cut the button before the resistor, that will isolate it from everything else. So now we're doing time. So R105 and R1016 are the two resistors for these two buttons, so we're just going to remove them, cut the tracks just to be safe, either side of the resistor because they're daisy chained, and then put the wires on the positive legs of the buttons. So again, nothing that we haven't done before. So now we have the call forward, flag forward. So again, cut the tracks to isolate the buttons from the links. Wire onto the positive legs of the buttons. I'm kind of skipping through this, as long as you know where to solder onto and how to isolate them, it doesn't matter too much. You've seen all this before. So what I'm thinking for these memory buttons and so is we can use them for controlling the browsing in Traktor. So we can program them to go between favorites, to go backwards or forwards between the browser sections. So this is the eject button. And then the jog mode switch. So there we go, all of the buttons wired in. So again, just like the other boards, we have VLED, which is the 12 volt for the LEDs. we have G LED, which is 12 volt ground, and we have GNDD, which is the ground for all of the buttons. Here we have an issue that I came across, which we didn't have on the Mark II. Now, we wire the 12 volt up just like before, and then we bring the LEDs high with 5 volt. But you can see all of the LEDs are lighting up when they're not isolated. So I'm wondering if something to do with the processor on the board, keeping them all of the outputs high for some reason. So we need to cut the track like we've done on the buttons to isolate the LED high commands from the processor. So we can see now when we test them, the buttons are separate and only those buttons are lighting up and nothing else is lighting up. So now we're going to do the loop commands. So this is very similar. We have a test point next to the transistor, which is the line that comes from the processor. So by cutting the track, we're isolating this LED from the processor, and then we are putting the 5 volt onto the transistor, which will bring the LED high. Some of them are not that close, so we've just had to use the multimeter, but you can clearly see what I've done there and how I've cut them. So this is the loop in. I'm trying to be careful of how I cut, but because we're kind of treating everything separate, don't be too worried if you do cut something that you're not supposed to. So we've cut that track to isolate it from the processor, and then we put the wire onto this test point. I shorted that out, so just double check your work, and then I put it on again without the short. So now we're going to do the hot cues. So the Mark III has 3 LEDs, whereas the Mark 1 and Mark 2 have 2 LEDs. So this is quite a bit different from before. Now each one of these I've done in a different way. This first one I've wired actually onto the leg of the transistor and cut the tracks at the side of it. A little bit fiddly, but because I wasn't sure where the Q1002 test point was, I decided to do this one in this way. I wasn't happy with that wire just there, so I just re-trimmed it and re-tinned, and that was a lot neater. So this next one, we have easy access to the solder test points, and it's easy to cut the tracks on the other side of the test points. And then we can solder onto the test pads. So that's those 3. And this one was even easier. So all of them have wire jumpers to go over those tracks. So those 3 just there, we just need to remove the jumpers, and that will isolate the LEDs from the CPU. And then we can solder onto those 3 points. Just make sure that they are actually cut, and then make sure that they're going to the right places. And then solder onto those pads. Now we're going to quickly zip through testing all the LEDs. So just like before, we're applying 5 volt to each one of those wires that we have soldered on to the LEDs, with 12 volt going to VLED. Now we're going to use continuity to test that the buttons work. So these direct buttons, like I say, they do have a resistor on them, so they will show some resistance when we're testing them, but as long as they close to a short and none of the surrounding buttons affect anything, that will be fine. So there we go, that is all of the LEDs working, all of the buttons working. Now we're going to move on to crimping these onto the headers and placing them onto the board. So that will be video number 5, and then once that's in place and we've tested everything, then we can start to look at the programming. This one was quite a lot of work, but nothing that we haven't done before. So thank you for watching, and I will see you on the next one.